Beneath the sand at Saqqara, in a tunnel system that runs deeper underground than a 5-story building is tall, there's a corridor lined with boxes. Not the curved, painted sarcophagi most people picture when they think of ancient Egypt. These are massive rectangular containers, each cut from a single block of stone, each weighing somewhere between 70 and 100 tons, each sealed with a lid that alone weighs as much as a loaded truck. Most of them are carved from granite, one of the hardest stones available to the ancient world, quarried hundreds of miles away and somehow delivered into a cramped underground gallery with a level of precision that still impresses engineers who study it today. There are 24 of these boxes documented in the main complex. 24 separate engineering problems, solved again and again, buried in the dark where almost no one was ever meant to see them. The question that's followed them since their rediscovery in 1850 isn't really, could humans have built this? It's a more interesting question. Who built them, when, and why go to this much trouble for something meant to stay hidden? Start with the numbers, because the numbers are genuinely worth sitting with. A single box is hollowed from one solid block of granite, with interior walls in places only a handful of inches thick. The interior corners are cut close to 90 degrees, and researchers who've measured them have reported flatness and squareness that hold up impressively well by any standard, ancient or modern. The lids, roughly 30 tons each, sit against the rim of the box closely enough that in the best preserved examples the seam is barely visible. Getting a lid like that into position in a tunnel barely wide enough to walk through, without cranes or hydraulics, and doing it 24 times over, is a genuinely remarkable feat of planning and execution. None of that is in dispute. What's actually being argued about, among archaeologists and stonework specialists rather than in the comments section of a video, is exactly how the ancient Egyptians achieved this particular combination of scale, material, and precision, and how much of it points to lost technique versus straightforward, well-documented ancient methods applied with extraordinary patience. The site itself was rediscovered by the French Egyptologist Auguste Mariette in 1850, and it's worth understanding what actually happened rather than the mythologized version. Mariette had been following a reference in an ancient text describing an avenue of sphinxes, and while excavating near the step pyramid, he found exactly that, a paved processional road lined with sphinx statues, leading to a doorway that opened down into the underground galleries. Once his team cleared the sand, they found a corridor cut through the bedrock, branching off into recesses that held box after box. Mariette's own notes describe genuine astonishment at the size and fit of the granite work, and he recorded that many of the boxes were found empty, with their lids still largely in place and nothing inside but dust. That detail gets repeated a lot in more sensational retellings of this story as though it's inexplicable, but it has a fairly mundane explanation once you understand the site's long history. The Serapeum wasn't built and sealed once. It was used, expanded, and revisited across many centuries, from roughly the reign of Ramesses II in the 13th century BC through the Ptolemaic period more than 1,000 years later, meaning the complex was accessible, known, and in active use by different generations of priests and officials for an extraordinarily long stretch of time. Ancient sites that stay in continuous use for that long get looted, cleared, reorganized, and reused constantly, which is a far simpler explanation for empty boxes than anything more exotic. It's also worth being precise about what these boxes were actually for, because the popular framing sometimes treats their purpose as a total mystery when it really isn't. The Serapeum was the burial complex for the Apis bulls, animals that held enormous religious significance in ancient Egyptian belief as the living manifestation of the god Ptah. Each Apis bull, once it died, underwent an elaborate mummification and burial process, and the largest, most elaborate stone containers were reserved for exactly this purpose. That's not a guess pulled from thin air. It's supported by inscriptions found at the site referencing specific bulls and specific reigns, by the broader archaeological context of the Apis cult at Memphis, which is documented across multiple sites and periods, and by earlier, smaller-scale Apis burials nearby that show a clear evolution in burial practice over time, starting with simpler wooden coffins and evolving toward these massive stone containers as the cult grew more elaborate and better funded. The scale of the containers reflects the scale of the religious devotion behind them, not a mysterious alternate purpose nobody can identify. Now to the part of the story that actually deserves careful attention. How ancient stoneworkers achieved this level of precision in one of the hardest materials available to them, without the machine tools we associate with this kind of tolerance today. This is where a lot of popular retellings take a shortcut, either by implying the tools simply didn't exist or by leaning on vague appeals to advanced lost technology. Neither shortcut holds up well against what's actually been documented at other Egyptian sites. Egyptologists and archaeometallurgists have physical evidence, not speculation, for how granite was worked in this period. Copper tools alone won't cut granite efficiently. That part of the skeptical case is entirely correct, but ancient Egyptian stoneworkers didn't rely on copper edges biting directly into the stone. They used copper or bronze saws and drills as carriers for an abrasive, typically crushed quartz sand, which is harder than the granite itself. The metal tool moved the abrasive across the surface. The abrasive did the actual cutting. This isn't a theory reconstructed after the fact. Museums, including the Petrie Museum in London, hold surviving drill cores and unfinished stone objects from ancient Egypt that show the exact spiral cutting marks left by rotary, abrasive-assisted drilling, and an unfinished obelisk still lying in its quarry at Aswan shows workers pounding marks mid-process, using hard hammerstones like dolerite to rough out shapes before finer abrasive grinding and polishing took over. None of that is hidden or classified information. It's on display and has been studied for well over a century. What that method actually produces, given enough time, is exactly the kind of result you'd expect from patient, skilled, well-organized labor rather than machine tooling. Surfaces that are extremely flat and corners that are extremely square, but that still show, under close measurement, the kind of minor variation that separates handwork from machine work. Careful measurement of the Serapeum boxes has, in fact, found small inconsistencies between individual boxes, not the kind of identical, interchangeable precision you'd expect from a shared industrial template, but the kind of close, hard-won consistency you'd expect from skilled crews working to a demanding standard across years, sometimes generations. That's a genuinely impressive achievement. It's also a fully human one, and treating it as inexplicable tends to undersell exactly how sophisticated ancient Egyptian stoneworking traditions actually were, rather than elevating them. The logistics of getting 70 to 100-ton blocks from a quarry hundreds of miles away into a narrow underground gallery are just as often framed as impossible, and just as often have a well-documented, if labor-intensive, answer. Ancient Egyptian relief carvings, including a well-known scene from the tomb of Jehuti-Hotep, depict exactly this kind of operation. Enormous stone blocks lashed to wooden sledges, dragged by large teams of men, with a worker pouring water or a lubricant onto the sand just ahead of the sledge's runners to reduce friction. Physicists and engineers who've studied this technique have confirmed that wetting sand ahead of a sledge can meaningfully reduce the effort required to drag a heavy load across it, which is a fairly elegant, low-tech solution to a genuinely hard problem. None of this means every step of moving these particular boxes into their final underground positions is fully solved. The tightest sections of the Serapeum's tunnels genuinely do raise hard, still debated logistical questions about maneuvering room, and it's entirely fair, and honestly more interesting, to treat some of those specific engineering steps as open questions that current Egyptology hasn't nailed down to universal consensus, rather than either dismissing them or leaping straight to claims of impossibility. Dating the boxes is another area where the real, careful answer is more nuanced than either the confident museum placard or the skeptical alternative usually allows for. Inscriptions on several of the boxes and chamber walls do connect specific sections of the Serapeum to identifiable reigns, particularly work carried out under Ramesses II and his son Khaemwaset, a prince and high priest who took a documented personal interest in restoring and expanding older monuments across Saqqara, including much older Old Kingdom structures nearby. That's genuinely useful evidence, not a weak or arbitrary anchor, because Khaemwaset's involvement at Saqqara is independently attested through multiple inscriptions and has made him one of the better documented figures in the history of Egyptian monument preservation and reuse. At the same time, it's fair, and it's the position serious Egyptologists actually hold, that the full construction history of the Serapeum spans a much longer period than any single inscription captures, with later galleries and later boxes added under 26th dynasty rulers centuries afterward, and continued religious use running all the way into the Ptolemaic era under Greek rule. In other words, the honest picture isn't one king built all of this in one reign, and it isn't we have no idea when any of it was made either. It's a genuinely long, layered construction and use history, documented across multiple independent inscriptions from different periods, which is a more complicated but far more historically interesting story than either extreme version. It's worth spending a little more time on the physical evidence for ancient stoneworking methods, because this is exactly the part of the story that tends to get skipped over in more sensational retellings, and it's the part that actually settles most of the how question. The core drills recovered from Egyptian sites and now held in museum collections aren't a minor footnote. Flinders Petrie, one of the founding figures of scientific Egyptology, documented and collected numerous granite core samples in the late 19th century that show clear, consistent spiral grooves cut into the stone, the unmistakable signature of a rotating tube drill working with an abrasive slurry rather than a static blade scraping the surface. Petrie calculated the pressure and rotational force those grooves implied, and while later researchers have refined and debated some of his specific numbers, the basic conclusion, that ancient Egyptian workers used rotary drilling technique on hard stone, assisted by an abrasive rather than relying on the metal tool's edge alone, has held up across more than a century of further study. That single piece of evidence answers a huge share of the impossible tools argument on its own, because it demonstrates that Egyptian craftsmen had already solved the core mechanical problem, cutting granite efficiently without hardened steel, centuries before the Serapeum's boxes were carved. The unfinished obelisk still lying in its quarry bed at Aswan tells a similarly direct story, because it's essentially a stopped-motion snapshot of the entire process. Workers abandoned it part-way through extraction after a crack developed in the stone, leaving behind clear evidence of the pounding technique used to separate the block from the surrounding bedrock. Rows of shallow depressions left by dolerite hammerstones, used not as chisels but as percussive tools to slowly crush and remove granite in a controlled channel around the obelisk's outline. That same basic technique, roughing out a shape through controlled percussion before finer abrasive grinding smoothed and squared the final surfaces, is the method Egyptologists point to for the Serapeum boxes as well, just applied at a scale and level of finishing patience that clearly represents some of the most accomplished stonework this tradition ever produced. It's not a different, unexplained technology. It's the same well-documented toolkit, pushed about as far as skilled, well-funded, motivated labor could push it. The role of Prince Khaemwaset in particular deserves more attention than he usually gets in popular retellings of this story, because he's a genuinely fascinating figure in his own right and a big part of why the Serapeum's history is more layered than a single-reign construction project. As a son of Ramesses II and a high priest of Ptah at Memphis, Khaemwaset developed what modern historians sometimes describe as an early form of antiquarian interest, personally overseeing restoration work on monuments that were already ancient in his own lifetime, including pyramids built more than 1,000 years before he was born, and leaving inscriptions recording his own restoration efforts on some of them. That documented habit, of an Egyptian prince deliberately going back to identify, restore, and inscribe his own name onto older monuments, is actually a well-established and independently attested practice, which matters a great deal for how we should read some of the Serapeum's inscriptions. It means the presence of a name on a section of the complex doesn't automatically mean that section was built from scratch in that ruler's reign. It may just as easily reflect a documented, historically attested pattern of restoration, expansion, and rededication by a person we know, from other sources entirely, had exactly that habit. That's a far more grounded explanation for any mismatch between inscription and stonework than an unexplained, two different civilizations scenario, because it's backed by independent evidence about who Khaemwaset was and what he's known to have done elsewhere. Anywhere ancient builders achieved a combination of scale, material hardness, and precision that looks startling at first glance, from the Great Pyramid's core blocks to the Aswan obelisks to sites like the Serapeum, a familiar rhetorical move shows up. Acknowledge the skill was real, then quietly imply that real skill isn't actually a sufficient explanation, without ever fully committing to what the alternative explanation is supposed to be. That rhetorical move tends to work by comparing ancient craftsmanship to modern industrial tolerances as though the two are directly equivalent, when what's actually being measured is the difference between mass-produced machine parts, built to be interchangeable across a production line, and one-off, hand-finished ceremonial objects built by highly specialized crews who might spend years working a single piece. Those are different kinds of precision, produced by different kinds of effort, and treating a difference in method as evidence of an unexplained mystery tends to say more about how unfamiliar we've become with what sustained, skilled, low-technology craftsmanship can actually achieve than it says about any gap in the archaeological record. None of that is meant to wave away every open question, because there genuinely are some, and the honest version of this story includes them rather than pretending everything is fully settled. Precisely how workers maneuvered the largest boxes through the tightest sections of tunnel remains a subject of real engineering debate among specialists, without full consensus on every step. The complete chronology connecting the earliest galleries to specific named rulers still rests partly on inscriptions whose exact relationship to the stonework beneath them deserves the same careful scrutiny any historian would apply to inscriptions on any reused or long-occupied ancient site. And the site itself, like most underground stone monuments in a region with rising groundwater and increasing humidity, is genuinely at risk from slow environmental degradation, which means the kind of careful, modern, instrument-based measurement that could settle some of these open questions more definitively is a genuinely useful, time-sensitive scientific project, not just a rhetorical flourish. What the evidence doesn't support, though, is the idea that human beings, using tools and techniques we have direct physical evidence for elsewhere in the archaeological record, were incapable of producing what's sitting in those tunnels. That claim isn't a bold, open-minded question. It's a specific factual claim that the existing evidence, drill cores, unfinished quarry pieces, transport depictions, comparable precision work at other confirmed Egyptian sites, actually argues against. The genuinely interesting version of the Serapeum story isn't a story about a mystery with no explanation. It's a story about just how far a civilization without powered machinery could push hand-tool precision when it had enough time, enough organized labor, enough accumulated generational skill, and enough religious motivation to make 70-ton stone boxes worth the effort, again and again, for objects that were then sealed away in the dark, never meant to be admired by anyone at all. That's not a smaller story than the one about impossible ancient technology. In a lot of ways, it's a bigger one because it's a story about what people, not machines, are actually capable of when the stakes matter enough to them. The Serapeum still has real secrets left to give up. Nobody has yet conducted a fully comprehensive modern instrument survey of every box in the complex, measuring flatness, squareness, and tool marks to the standard that could settle some of the finer open debates about exactly how each one was finished and exactly when each gallery was carved. That's a genuinely valuable piece of unfinished archaeological work, sitting underground in a slowly deteriorating environment, waiting for someone with the funding and the access to actually do it properly. But "we haven't finished measuring everything yet" is a very different claim from "this couldn't have been built by the people credited with building it," and conflating those two claims is where a lot of popular retellings of this story go wrong. The real Serapeum doesn't need an impossible explanation to be remarkable. What ancient Egyptian stoneworkers actually pulled off here, quarrying, transporting, and finishing dozens of 100-ton granite boxes to a tolerance that still earns respect from modern engineers, using tools we have physical evidence for and techniques we can still watch depicted on the walls of other tombs, is already one of the most impressive sustained engineering achievements of the ancient world. It doesn't need to be reframed as evidence of something else to earn that description. It already is that, on its own terms, built by human hands, in the dark, for reasons that mattered enormously to the people who put them there.